All right, in this video, I'll be going over how you can use the compounding interest formula to solve for time if you don't know the time. And that's kind of the hardest version of using the compounding interest formula. Solving for the initial amount, the principal, or the ending amount, or the rate are generally easy because they don't involve logarithms or exponents. But solving for time does. So let's go over that. So let's write our formula down here. A equals P times 1 plus R raised to the power of T. That's a T. T for time. All right, so T is what we don't know, so that's going to be the exponent. Everything else we should know, though. So in this case, we have $1,000 that's invested. That $1,000 that gets invested is called the principal. It's invested at an APR, which stands for annual percentage rate, at 10.75%. That's a good rate. And then over a certain period of time, we don't know the time. Time is unknown. The account has increased to $3,400. And the $3,400, that is the A. That's the amount. That's the future value of our money. So we're going to go ahead and substitute those numbers into our formula. We got 3,400 is equal to $1,000 principal times 1 plus the rate, which is 10%, written as a decimal, is 0.1075 raised to the power of, I don't know, so we call it T. All right. To be honest, there's two different things you can do here for the first step. You could go ahead and simplify this number inside the parentheses. So you could add this together and make it one number. Or you could divide off your 1,000 first. So either thing's fine. I'm going to add that number together there. So when you add those together, you should get 1.1075 to the T. And then the next step, I'm going to divide my 1,000 on both sides. All right, so if you're solving an exponential equation, when you find the exponent, the variable that's in the exponent, whatever it's attached to, so whatever its base is, you want to get everything else other than its base and its exponent away. And so that means my 1,000 has to go away. So I divide both sides by 1,000. And 3,400 divided by 1,000 is 3.4. And then what I'm left with on this side is 1.1075 raised to the power of T. And here's where we have to introduce a logarithm. All right, so the power of T, or that T is an exponent. It's really hard for me to solve for that when it's an exponent. So I don't want it to be an exponent anymore. And so I have to use a logarithm to bring that T down out of the power. So I'm going to do the logarithm of both sides. And this is the common log. So log of the left, log of the right. And on the right side, we can use our property that's an exponent property. It says if we have the logarithm of something to a power, the power can go out front. So we're going to bring that power out front. I'm running out of room here. So this side is T times the logarithm of this number, 1.1075. And this number on the left is something. I could take my calculator, type log 3.14 and write down what it is. But for now, I'm just going to leave it as log of 3.14. So that when I get to the end here, I'm only really going to have one step to figure out what T is on my calculator. And then the last step to solve for T here, we got a T. We got log of this number. We're going to divide off everything except for T. So we're going to divide off log 1.1075. I don't have any room down here, but that's what so we're dividing both sides by log of 1.1075. Okay, and so then I'm going to have T by itself. And so what's on the left there is going to be my answer. All right, let's clear this out. So it's going to be log of 3.14. So log 3.4. There we go. Divided by the log of 1.1075. Close parentheses, enter, and we get 11.98. So that's our answer for T. So T equals 11.9, and if I'm rounding, 99 would be better. So almost 12 years is how long that one would take. All right, I got one more example here to cover. So let's get straight to it. A Sash's teacher wins $200,000 playing the lottery, and he decides to invest his money in the stock market, which is going to make approximately 9.8% per year. He wants to have $1 million when he retires. So how many years does he have to wait until he retires? So how many years is it going to take $200,000 to turn into $1 million if I'm getting 9.8% per year? All right. So remember your formula again. A equals P times 1 plus R to the T. All right. Our 200,000 is our principal. 200,000 is our principal. Our amount that we need is $1 million. Okay, and our rate is 9.8%. So that's 0.098. And our power of T is just there. I need to find T. All right, so again, first step, going to be adding these numbers together in this parentheses. So that's 1.098. Okay. And then what I'm going to do is also in the same step is I'm going to divide off this 200,000 from both sides. So that would have been my next step. There we go. And so 1 million divided by 200,000 should be 5. And on the right side, I have 1.098 to the power of T. Okay, and now I have my base to the power of T. I've got everything else away from this exponent, so now it's time for me to do my log of both sides. So go log of the left, log of the right. So again, log of 5 is just a number, and I could type that in my calculator and I can figure out what that is. But for now, I'm just going to wait. I'm going to wait on that. So I can just type the whole thing in at the end. And so what happens here when I do log of both sides is my power of T, based on the one property of logarithms, is that T is allowed to come out front now. So now this side changes to a T out front times the logarithm of 1.098. And the left side is still the logarithm of 5, log of 5. And now I have T multiplied by the log of this number. And the log of anything is a number. So this is T times a number. So if I want to get rid of that number that's attached to T, I would just have to divide by it to get rid of it. So we have log of 1.098 dividing by both sides. Okay, and then all that stuff on the left, that's going to be my answer. So take out your calculator. And we're going to do, again, log of 5. So if you don't know what that number 5 represents, it represents that your money you're looking for 5 times the amount you started with, right? So the first step I did was took 1 million and divide by 200,000. I took the number that I need to have and divided by what I started with and got 5. So that means that I need to 5 times my money. And then the number that we're dividing by, log of 1.098, that's basically just 1 plus whatever rate I'm getting per year. So that happened the same thing with the first example. So log of 1.098, close parentheses. My guess is about, 16, 17 years? There we go. Yeah, so 17.21 is T. So that's going to take about a little over 17 years. So not that you need to know this, but a quick rule of thumb for the stock market. Because the stock market earns about 9.8% every year, what that means is that your money should double just about every 7 years. So that's a rough estimate. But if you invest in the stock market, and most of you will, because your retirements will be invested for you in the stock market. Your money should, as long as everything is going according to plan and things don't change drastically as they did the last 100 years, your money should double every 7 years. All right. So to think about that, I needed my money to double twice plus a little extra. So that's why I was able to estimate about 17 years, because doubling twice would be 4 times the amount. And that would only have gotten me to 14 years. So, but yeah, so that's it for this video.